You stride into the kitchen with purpose, cross the threshold, and your mind hits a wall of static. The goal you had just vanished. Or perhaps you're staring at a textbook, realizing your eyes have scanned the same paragraph 4 times, while your consciousness remained miles away. This sudden mental fog often feels like a personal defect or a lack of intelligence. However, your biology is executing its legacy code exactly as intended. We are forced to navigate high-speed digital environments using a software suite designed for Paleolithic survival. The hardware hasn't changed, but the requirements have. This mismatch is most visible when you study for days, only to have your vocabulary evaporate the moment the exam begins. This comparison shows the neurological response to a test on the left and a predator on the right. Your ancient hardware treats a failing grade as a lethal physical threat. Careful recall is a slow, resource-heavy process. When the panic pathway activates, it overrides the slower logic centers to ensure an immediate, instinctive reaction. The brain suppresses working memory to keep the system lean, preparing the body to sprint away rather than sit and reflect. The survival instinct simply pushes memory aside, prioritizing an escape route over an essay answer. When life isn't on the line, the brain focuses on a different priority, hoarding every possible calorie through an aggressive energy conservation mode. This is why reading autopilot occurs. Your brain keeps the low-energy visual systems running so you can see the words, but it cuts power to the calorie-hungry comprehension centers to save fuel. This same drive to protect your energy reserves is the engine behind procrastination. When a task is vague or difficult, your brain enters a high-performance simulation mode to calculate every potential risk. This mental modeling burns through glucose rapidly, causing the caloric cost on the scale to spike.
To prevent exhaustion, your brain signals avoidance. Fatigue drains the prefrontal cortex battery, managing willpower. When it hits 0, a restraint offline warning triggers. With the planning center dark, you lose the ability to consider long-term consequences, leaving you to act on immediate, impulsive whims. Delaying important work and choosing short-term distractions are the results of a biological accounting system trying to keep the lights on. This efficiency also dictates how your brain manages data within your daily surroundings. To keep things organized, the brain ties short-term goals to the specific physical room where they were formed. Moving through a doorway tells the brain that the previous context is no longer relevant. It clears the mental cache at this threshold to prepare for new information in the next room. A similar shortcut affects how you process social information, creating a vulnerability known as the illusory truth effect. In a prehistoric environment, encountering the same thing repeatedly usually meant it was safe. Frequency became a proxy for security. Because familiarity feels safe, repetitive claims can bypass your skepticism. If you hear a statement often enough, it begins to feel like a fact, regardless of its accuracy. The default system values physical safety over memory and prioritizes familiar feelings over verified facts. Operating on these default settings leads to a cycle of missed deadlines, shallow learning, and a constant susceptibility to the algorithms scrolling on the screen. While we cannot replace our biological hardware, understanding these specific flaws means we can predict when they will occur. You can recognize the moment your brain tries to switch to autopilot and use that awareness to stay engaged. To build a toolkit for managing these cognitive blind spots, subscribe and join our community. Gaining insight into these prehistoric remnants allows you to compensate for your biology, ensuring you drive your actions rather than being driven by ancient glitches.